Dear students, this is Kavita Base. In this session, I will explain how to derive the equations for average velocity and RMS velocity of gas molecules using Maxwell's law of velocity distribution. This topic is related to BSc course Physics subject, paper 3rd, Thermal Physics, Radiation and Optics 1, and this topic is in the chapter Thermal Physics of Unit 1. Let us start the session. As we know that the average velocity of the gas can be defined as the average of velocities of all the gas molecules. In equation, it is given by 1 by n into integration from 0 to infinity C into dn. Here n represents total number of gas molecules in the system and this part represents the sum of velocities of all the gas molecules. Then finally this equation represents the average velocities of all the gas molecules. This is the average velocity equation. Then, according to Maxwell's law of velocity distribution, we have dn by n is equal to 4 pi a cube e to the power minus b c square into c square dc. This equation is from the Maxwell's velocity distribution equation. This is nothing but Maxwell's velocity distribution equation. We have discussed this equation in the previous session. Then, on substituting this value in the above equation, we get V average is equal to integration from 0 to infinity C into 4 pi a cube e to the power minus b c square into dc. Again, on rearranging the terms in this equation, we get that is 4 pi a cube is a constant term. Then write this 3 times outside the integral sign. Then this c is multiplied with c square. Then we get c cube. Then this equation becomes 0 to infinity integral sign e to the power minus b c square c cube dc. In the next step, we have the expression for average velocity, that is 4 pi a cube integration from 0 to infinity e to the power minus b c square c cube dc. Here this part represents one of the standard integral and its value is 1 divided by 2b square. Then in the next step we have the expression for average velocity, that is equal to 4 pi a cube divided by 2b square. Again, on substituting the value of a, that is b by pi with power of, then we get V average is equal to 2 into pi to the power minus of and b to the power minus of. Next, again on substituting the value of b in this equation, we get V average is equal to 4 into 2 kT by m. Here B is equal to m divided by 2 kT and m represents mass of each gas molecule, K is Boltzmann constant value and T is the absolute temperature of the gas. Then this 4 is due to this 2. That is 4 into, on substituting the value of B, 2 kT by m, that is finally we get V average is equal to square root of 8 kT by m. Then on simplifying this term, that is square root of 8 by pi is equal to 1.59. Then square root of kT by m. This equation represents the average velocity of gas molecules. Next, we will have a discussion on the equation which is representing the root mean square velocity of gas molecules. The root mean square velocity of the gas molecule can be defined as the square root of the mean of squares of the velocity of all the gas molecules. In the next step, we have the equation, that is 1 by n integration from 0 to infinity c square dm. This equation represents mean of sum of squares of velocities of all the gas molecules. Here n represents total number of gas molecules in the system, and this part represents sum of the squares of velocities of all the gas molecules. Then this term is multiplied by n, that is total number of gas molecules. Then that equation represents mean of sum of squares of velocities of all the gas molecules. Then by using Maxwell's velocity distribution equation, that is dn by n is equal to 4 pi a cube e to the power minus b c square into dc, we get the equation, that is mean square value, mean of squares of velocities of all the gas molecules, that is equal to 4 pi a cube integration from 0 to infinity e to the power minus bc square into c to the power 4 into dc. Again, by using one of the standard integral, that is this part represents another standard integral, and its value is 3 by 8 1 divided by b square into square root of pi by b. On substituting this value in this equation, we get 4 pi a cube 3 by 8 b square into square root of b by pi. Next, on simplification, we get 3 divided by 2b. Here also, on substituting the value of b, that is b is equal to m divided by 2 kt, finally we get 3 kt by m. This equation represents only the mean of squares of velocities of all the gas molecules. So, on taking square root on both sides, we get root mean square velocity, that is square root of mean of squares of velocities of all the gas molecules, that is square root of 3 kt by m. Then root 3 value is 1.732. Then finally, root mean square velocity of the gas molecule can be written as 1.732 into square root of kt by m. This is the expression for RMS value of gas molecules. Then these are the reference books. Then thank you.